All right, welcome back, everybody. This is Calvin Nellum. We're talking about telescopes now. We're talking a lot about astronomy right now. We got to get into the main instrument that we use to study astronomy, right? The big things. And so we're going to talk about aperture whenever we're talking about any type of telescope. This is really important because aperture is what really determines the efficacy or the effectiveness or just how good the telescope is. Okay, and essentially the aperture is just it's really just the diameter, and the diameter is just the length or the width of the circle. Okay, so whenever we're talking about diameters, whenever we're talking about aperture, we're just talking about how wide the circle is. Okay, so if we look at these telescopes here, we have a regular telescope, and then we have the amazing Hubble telescope, which is a satellite telescope that we use to just, to really study galaxies. And we look at the aperture here, we see that the Hubble is a lot bigger, correct? Right? Much has a much wider aperture compared to a standard regular telescope. Okay, and we're talking about diameter. Where we're talking about aperture, we're talking about diameter. We're talking about diameter. We're talking about aperture. And one thing we know in geometry is that when we divide the diameter into two, we get the radius. Okay, and we care essentially about the area of this circle. Okay, we care about that because this is what we are going to see when we are looking through that telescope. We call that in astronomy the collecting area, because that is the area that you are going to see when you look inside of that telescope. And this is a part of the aperture which determines essentially just the effectiveness of your telescope. Okay, so if we look at our Great River Learning tool, all right, we have the dimensions, and essentially they're giving us the diameter and the collecting area of a variety of different apertures or variety of different telescopes, correct? And so if we look at the Hubble telescope, it says that we have a diameter essentially of 2.4, and it gives us a collecting area of 4.5. Let's prove that. So we said we have a Hubble telescope. Okay, so they give us the Hubble telescope, which has a diameter or D of 2.4 meters. Okay, and if you don't know what a meter is, if you take your arm and you extend it from left to right, okay, it's about 3 of those. So that's just how wide this aperture is, or the diameter of the Hubble telescope is. Okay, and what the equation, or the pretty much the equation we're going to use, since we're giving the diameter of 2.4 meters, we're going to use the area of a circle equation, which is essentially the way that we figure out the collecting area. Remember we was talking about earlier, the collecting area of that diameter and circle that we see. Okay, and so we look at it and we want to put it in terms of what we have. So again, we know that the diameter is half of the radius, right? So the diameter is half of the radius, then I can just change this equation to just d, which is diameter, divided by 2, right? And it stays squared. Okay, and now we have our equation in terms of our known, which is what we want. Duh. Okay, and so now we're going to go ahead and plug and chug, and we're going to put in our answer with our equation. So we have this new equation, which is area equal to pi divided by diameter, which is 2.4, divided by 2, quantity of squared. Okay, so you're just gonna take out your calculator and you're gonna just do that math. So I always like to go to just Google calculator, keep it really simple. All right, so we have 2.4 divided by 2. That gives us 1.2. Okay, so we have a calculation of 1.2 squared. All right, and then when we go ahead and finish to get our answer, we have the areas equal to pi of 1.2 squared. So let's go ahead and do that math. So we're going to square. All right, so that's 1.44 times pi. So that gives us a collecting area. We go up to 2 numbers after the decimal. So we have an area of 4.52, and this is in meters. So because we squared it, it's going to be meters squared. And then that should match our collecting area here.